Good morning, everybody. Okay, so perhaps we could start this morning. So I'm very pleased to welcome you today on behalf of the RESPECT project, which has the honor to be the coordinator. And so welcome for a morning of information exchange on the recent Law European Critical Raw Material Act. So I'm Justo Garcia, so I'm working for Orano, that a French company that decided to expand its activity on the battery recycling. And so yesterday, Orano signed an agreement with XCC New Energy to create two joint ventures for the manufacturing of precursors and cathode active material. And so these two plants will be located at Dunkerque in the north of France. RESPECT project is funded by the Horizon Europe Research and Innovation Program and propose an innovative solution for the recycling of different ranges of batteries to support the development of a competitive, circular and sustainable European battery manufacturing industry. The event proposed by RESPECT project is entitled Critical Raw Material Act, Dream or Reality? Perspective from the RESPECT project. Our modest intention is to explore how the RESPECT project can contribute to closing the gap between the aspiration of the Critical Raw Material Act and the practical realities of achieving a secure, sustainable, and circular European Lion battery manufacturing industry. We hope that the attendees present here in Brussels, but also present online, will have the opportunity to learn about the challenges and opportunities presented by the circular economy regulation on material containing critical raw material for the lithium-ion battery sector. It will also feature a discussion on the innovative solution developed by the RESPECT project for green and efficient Lion battery recycling, with a focus on translating funding into policy recommendations and fostering collaboration among stakeholders. Our event is then organized in two parts. The first part will be addressed by several interventions from representatives of the EU Commission, stakeholders of the batteries value chain, and some partners of the RESPECT project, in order to address many aspects and insights of our subjects. Our first speaker will be Mrs. Maria Nieberg from the DG GROW, who will present the Critical Raw Material Acts and its implementations. Then Edouard Antix from CINEA will present the Horizon Europe program. The next will be Franz Geyer from BMW, will present the EOM point of view regarding recycling and circular economy. And the RESPECT partners will provide some insight regarding CERMA challenges and opportunities. Okay, Antoine Driancourt from CEA will highlight some key technologies results achieved by the project. Enrique Moliner will share some results of the life cycle assessment of the current end-of-life routes for lithium-ion battery. Finally, Guillaume Barbe from Siva Logistics will focus on the logistics challenges regarding the CERMA. To conclude this sequence, Fabrice Tassin from Umicore and also from BEPA will present the role of the BAT4EU partnership and the BEPA in supporting the CERMA Act. The second part will be a panel discussion with some speakers from the first part, and also two additional panelists, Johan Blondel from DG RTD and Andreas Forvang from Vinod, and the partner. So they will share some insight on our RESPECT project, but also innovation in the battery value chain can support policy making at the European level. Before we give the floor to our eminent speakers, I would like to introduce more deeply the RESPECT project and provide some insight about the CERMA Act. Okay, so coordinated by Orano, the RESPECT project is funded by the Horizon Europe Research and Innovation Program and the Battery European partnerships. The project seeks to reshape the battery recycling landscape through a disruptive pre-treatment process, dual extraction routes, and a commitment to maximize material valorization. 18 partners from 9 European countries have joined their force to develop an innovative recycling process. Respect project gathers multidisciplinary partners, which imply a holistic approach to addressing challenges and opportunities related to the battery ecosystem. The partners are coming from France, Orano, CEA, Coupe Indus, and CEA Logistics, Spain, Lomartov, Siletec, Belgium, Clarence and Klepa, Norway, Morrow, Vinod, Sweden, Chalmers, Finland, Aalto, Mezzo, and Germany, Fraunhofer, Münster University, and from Switzerland, 2 associated countries, Switzerland, Keyboards, and United Kingdom, Adibel and University of Warwick. Respect aim to achieve efficient, sustainable, innovative, and safe battery recycling processes in the EU, encompassing new processes capable of achieving more than 90% in weight of recovery rate and efficiency, and supporting lithium-ion battery manufacturing in Europe. The objectives of the RESPECT project are self-deactivation of lithium-ion battery, limiting environmental impact, raw material, and cost. Development of 2 innovative and low-carbon recycling routes, hydrometallurgy and direct recycling, full recovery and high valorization of material, implementation of an efficient logistical solution for lithium-ion batteries, and improvement of the life cycle assessment of the battery value chain. The vision of the RESPECT project is to contribute to paving the way for increasing global competitiveness, strategic autonomy, and circularity of the European battery ecosystem by developing innovative green recycling material recovery processes and thus supporting the growing lithium-ion battery manufacturing in Europe. The RESPECT project ambition is to close the loop of the lithium-ion battery recycling. This is to be achieved through the design, development, and implementation of green recycling processes. 2 routes are investigated. Full hydrometallurgy route, so an innovative pretreatment process, which is versatile and capable of treating varying feedstock from end-of-life module and battery to scraps, with varying chemistries, geometries, and state of charge. The pretreatment includes a disruptive deactivation process followed by successive separation and recovery, thus allowing the production of high-quality black mass and the recovery and valorization of graphite, copper, and aluminum. Employing full hydrometallurgic processes, ensuring environmental safety and health consideration are paramount for the recovery from black mass and production of battery-grade salts, namely nickel, cobalt, manganese, and lithium. The second route is a direct material recycling route. It is a novel recycling approach aimed at restoring the composition and structure of the degraded cathode material to its original state. The direct recycling route bypasses the hydrometallurgical steps and presents many advantages in terms of low carbon footprint, reduced energy consumption, and ability to recover different cathode materials. The recycling process performance is validated through the manufacturing and the testing of new cathode and anode material at the cell level, which incorporates recycled material from RESPECT processes. After the brief presentation of the RESPECT project, I will introduce some figure about the context and also the critical raw material. So as you know, electrical car sales have witnessed a massive growth with around 40 million vehicles sold in 2023, and this trend is expected to continue in the future, with forecasted predicting it to be doubled or tripled by 2030. In Europe, new electric car registration reached nearly 3.2 million in 2023, increasing by almost 20% relative to 2022. These positive trends provide excellent opportunities for the emerging recycling market and for establishing the recycling industry in the EV ecosystem. Manufacturing scraps and end-of-life battery constitute the main feedstock for the recycling industry. With the deployment of the gigafactories to cater the need of EV sector, production scrap accounting for as much as 30 to 40% of the output during the ramp-up phase of this gigafactory will be produced. They will remain the primary source of feedstock for recycling until 2030, and followed by end-of-life module from vehicle after this period. With an anticipated 30 million EVs on the European roads by 2030, the imperative of efficient, safe, and sustainable battery recycling processes has become more crucial than ever. Faced with a growing need for critical raw material to support the energy transition and the electromobility, recycling could become the most important part in the battery industry. Recycling can become a major source of supply of critical raw material for Europe, securing the access of this raw material, ensuring stability of the supply chain, and controlling the cost and pricing of these materials. Recycling contributes to the preservation of the environment and also the preservation of the natural resources. Recycling reduces also CO2 emission and energy consumption. Even if the EV lithium-ion battery recycling has many assets, it is facing multiple challenges. Recycling must demonstrate its competitiveness. Recycling must be versatile, allowing the treatment of different batteries and chemistry, and should also anticipating the change of technologies. And recycling must provide high-quality recycled material to the battery manufacturers. Primary material demands can be further reduced by recycling. Then recycling offers Europe the potential to secure the resource it needs. By 2050, recycling can give Europe a major supply source. To foster the green ambition, Europe has strengthened its regulatory framework and adopted initiatives to promote the circular economy and thus ensures the sustainability and competitiveness of an European battery value chain. I listed main initiative, so the important project for common European interest. This initiative consists of on member states aid to support for highly innovative industry-driven projects demanding high funding intensities, long-term impact through R&D, and first industrial deployment. The second, that important as we'll discuss after, it's a Critical Raw Material Act. So the European Critical Raw Material Act is an initiative of the European Commission to ensure sustainability and secure supply of critical material in the European Union. Also, the Net Zero Industry Act aims to boost the competitiveness of the European industry and technology crucial for decarbonization. The goal is to address barriers to scaling up production in Europe, simplifying the regulatory framework and allowing fast-track permitting. The battery regulation. European Union adopted regulatory framework and initiative to a regulation dedicated to the battery that entered into force in July 2023. The regulatory framework is strengthened to promote the circular economy with binding collection and recycling rates and allowing access to waste and end-of-life batteries. Finally, the last is a temporary crisis and transition framework. It's an initiative aiming to cushion the economic impact of Russia aggression and support European companies in transitioning towards the net zero economy. This initiative consists of member state aid for the production of battery, their key components or recovery of raw material. We have chosen to focus on the two main provisions of this European framework. Firstly, I will look the main targets of the battery regulation. We'll then present the main objective of critical raw material acts. The European, as I mentioned, so the European Union adopted a regulatory framework and initiative to the regulation dedicated to the battery in July 2023. This regulation aims to modernize the regulatory framework to ensure the sustainability and competitiveness of the European battery value chain. The text introduced mandatory sustainability requirements, such as rule on carbon footprint, minimum recycled content, performance and durability criteria, safety and labeling requirements for the marketing and commissioning of battery, as well as end-of-life management requirements. The battery regulation also lays down due diligence obligation for economic operators with regard to the sourcing of raw materials. The regulation covers all battery placed on the European market, portable battery, automotive batteries, electric vehicle batteries, and industrial batteries. The RESPECT project aligns itself with the battery regulation objective, allowing the European Union to become a pioneer in the decarbonization of its road transport sector. By manufacturing and testing new cells, including recycled material, the RESPECT project will demonstrate the achievability of the European objective. A few words about the CRM Act. The European Union has reached an agreement for the CRM Act at the end of 2023. This act aims to reduce the dependency on source country and ensure a secure and sustainable European supply chain. This will be important not only for the lithium-ion battery market, but also for other sectors. The document outlining these agreements classify 34 raw materials as critical and 17 raw materials as strategic. Material most relevant for the lithium-ion battery market that fall into both critical raw material and strategic raw material include lithium, manganese, natural graphite, and nickel, alongside cobalt being listed as a critical raw material and copper being listed as a strategic raw material. The European legislator agreed on several objectives to be achieved by 2030. First, no more than 65% of the EU supply of each strategic raw material should come from a single source country for reducing the EU dependence on source country and diversifying its supply of strategic raw material. Secondly, at least of the annual consumption of strategic raw material should originate from EU extraction. Thirdly, at least 40% of the EU annual consumption of strategic raw material should be processed in the European Union. Finally, at least 25% of the EU annual consumption of strategic raw material should be recycled. After these few introductory remarks and sharing information of the project and the general context on the battery recycling in Europe, it's time to listen our speakers. We will enlighten us on the subject that interests us, Critical Raw Material Act, Dream or Reality, perspective from the European project. So now I will introduce you Maria Nieberg. So Maria Nieberg is a policy officer at the European Commission. So please. So she is responsible for the EU policy on the single market, industry, entrepreneurship, and small business, specializing in the sustainable and secondary raw material, as well as framework for primary raw material. Her work focuses on supporting industrial competitiveness and promoting circularity by ensuring access to sustainable raw material. Yeah.
Much for the nice introduction. I'm very happy to be here. Just to say that, and thank you for the overview that you provided. So just to orientate you where I am located in the European Commission. So it is in DG Grow, so the Directorate General for Industry, Single Market, Entrepreneurship and SMEs. And we are the team dealing with raw materials and energy-intensive industries, and it is we who have come forward with the Critical Raw Materials Act. Just to orientate you, our sister unit, who is in the same directorate, is responsible for the batteries regulation together with a team in DG Environment. So it's a co-led legislation by DG Grow and DG Environment. And it is also that sister unit who has come forward with the Net Zero Industry Act. So we are ticking some of the boxes that you presented. Let's see. This is forward. Yes, just a little bit the policy context of why we have taken this initiative. So we all know the attention on critical raw materials that has been growing exponentially in the past years, and the need for action on raw materials comes from our decarbonization goals and the growing need for raw materials for the manufacturing of the necessary technologies for the green and digital transition, and also for raw materials in defense and space applications. And we also have a context of geopolitical instability, where it is really crucial for Europe to develop our domestic value chain for critical raw materials and to diversify our external supplies. So as of last week, we have a new commission in place, continuing to be led by President von der Leyen. And at the beginning of this new political cycle, it is clear that ensuring a secure and sustainable supply of critical raw materials is at the very top of the European policy agenda. So thank you very much for having made the overview of the CRM Act. So you went through the benchmarks already. So to get to the benchmarks, to achieve them, you know that we have launched a call for strategic projects that was launched the same day as the Critical Raw Materials Act entered into force, 23rd of May. We are already in the process of evaluating these applications for strategic projects, and we received no less than 170 such applications. And we aim to have the list of approved strategic projects in the Q1 of next year. The applications cover many of the strategic raw materials identified under the Critical Raw Materials Act. Of course, that is the condition. So we cover the battery CRM, we cover rare earths and all stages of the value chain. And we have some 30 applications on the recycling stage. So we are working closely with the financial institutions to ensure that strategic projects get to life, and member states will need to do their part when it comes to actions to facilitate more streamlined permitting. We also see that the number of member states are setting up raw materials funds to be able to financially support CRM projects. We are setting up a joint purchasing platform for raw materials, aggregating demand and supply, and to facilitate offtake agreements. So the strategic projects, they will need to meet a certain number of criteria. They need to deliver by 2030. They need to be technically and financially feasible. They need to meet high ESG criteria, and they need to have a cross-border benefit. So sustainability and circularity is really a main pillar all through the CRMA proposal. So zooming in into the circularity dimension. So this picture shows the end-of-life recycling input rate of the 17 strategic raw materials. We have large-scale functional recycling of metals like copper and platinum group metals already today to the right-hand side. But a wide number of CRM on the left-hand side have practically no industrial scale functional recycling, which you are very familiar with in this consortium, I believe. For example, lithium. So we need a range of actions to improve this situation. And what are we proposing? Article 26 of the Critical Raw Materials Act relate to the setting up and implementation of national circularity programs to moderate the expected increase in demand of CRM and to increase the recovery of CRM from a number of products, components, and waste streams. These circularity programs will include promoting reuse and repair of products and components with relevant CRM recovery potential, increase collection rates of CRM-rich waste, support high-quality recycling and the use of secondary critical raw materials, for example, by taking into account recycled content in public procurement requests. We will come forward, the Commission will come forward with a list of products, components, and waste streams pointing at the relevant CRM recovery potential with secondary legislation next spring in May 2025. And after this, building on this, member states will have 2 years to come forward with their respective national circularity programs, so in May 2027. We are also targeting specifically the potential of recovery of CRM from extractive waste facilities with provisions both for operators and member states for active and closed extractive waste sites. Article 28-29, we zoom in on permanent magnets that include rare earths, and we have measures to increase their recyclability at the time they will reach end of life. So similar to the batteries regulation, we have information and labeling requirements, and this will apply by November 2027 for a number of products placed on the market containing permanent magnets. And then rules will also apply on making publicly available the share of a number of CRM in permanent magnets. And at a later stage, we will come forward with recycled content minimum share rules for specific permanent magnet CRMs. We also have the empowerment to set information requirements on the environmental footprint of CRM placed on the EU market to help buyers make more informed choices. This is a little bit inspiration also from batteries regulation that has the carbon footprint. So we will look on the most relevant CRMs for this action, and we will limit it to the 3 most important environmental footprint categories. It's a bit broader than in the batteries regulation, but it will always include the carbon footprint. And as you pointed out, we need to take not only the CRM Act, of course, into consideration, but other sectoral legislation. You went through the batteries regulation. There is also the regulation of end-of-life vehicles that the Commission proposed in July last year, and that is in co-decision process at this stage. And here the purpose is to increase CRM recovery from end-of-life vehicles with specific requirements on design for dismantling, removability, and recycling of CRM relevant parts and components from vehicles. So watch out for that one. As we move into the new political cycle, we will further raise the bar towards higher circularity. And as part of the Clean Industrial Deal, we will come forward with the Circular Economy Act with measures to create market demand for secondary materials and establish a single market for waste, notably in relation to critical raw materials. Our Executive Vice President, Mr. Stéphane Séjourné, will be working together with the Commissioner for Environment Files, Commissioner Rosvall, on this file. So to conclude, with the CRM Act, we want to fast track the path towards the delivery of a sustainable, resilient supply of primary and secondary raw materials to increase Europe's capacities for green, digital, space, and defense applications in close cooperation with our like-minded partners. So many thanks for being able to present the Critical Raw Materials Act in this context. I hope you have a good event. For anyone who is registered for the Raw Materials Week, on Thursday, we will have a session in the afternoon, or an event rather, on towards higher circularity of CRM. So anyone who is registered, would be good if you could join this event also, and perhaps take part in the discussions, because we will have a dialogue with the audience. Many thanks. Any need for clarification or any thoughts or comments or questions?
So now, I will introduce you. Edouard Antix, that is a project officer at the European Commission CINEA, managing battery recharge project under Horizon Europe. With a background in physics, political science, and material science, he specialized in energy storage and conversion technology. So Edouard will present us Horizon Europe project, innovative recharge toward a secure, competitive, and sustainable supply of critical battery material. Please.
Thank you very much. Good morning. Thank you for the invitation to this event. I'm very happy to be here, as I'm the project officer of Project Respect, and I work in the European Climate Infrastructure and Environment Executive Agency. And as I'm working especially in the Horizon Europe program, I would like to give an outlook on how Horizon Europe supports innovative research towards a secure, sustainable, and competitive supply of critical battery materials. So I'd like to start by a quick introduction of CINEA. CINEA was established to deliver the EU Green Deal by implementing funding for energy, climate, transport, and digital solutions. It will do so by managing EU funding of 65 billion euros by 2027, with the help of a dedicated staff of 600 workers. And by doing so, the project portfolio of CINEA will increase to 4,000 projects by 2027. So the projects managed by CINEA cover the different technology readiness levels, starting from laboratory scale, which is covered by Horizon Europe, and also pilot scale, which is also the focus of Horizon Europe, while there are other funding programs also managed by CINEA, which aim to deploy and upscale solutions for the green transition. And these are programs like the Innovation Fund, Connecting Europe Facility, and the LIFE program. So having a higher focus on Horizon Europe, I would like to show you here that Horizon Europe is the EU's key research and innovation program, as it will invest 95.5 billion euros by 2027. And the funds are distributed among three main pillars. Among them, there is Pillar 2, called Global Challenges and European Industrial Competitiveness. And all battery projects are funded within this pillar, and more specifically within Cluster 5, Climate, Energy, and Mobility. And again, within that, there is the BAT4EU partnership, which is responsible for designing the work program and the calls. So the BAT4EU partnership is a partnership between two sides, the public side, the European Commission, which is represented by different director generals, and on the other hand, private side, an association called BEPA, which gathers 230 private stakeholders from the industry and research. So both sides work together to set the European battery strategic research agenda to define the main priorities. And together they develop the Horizon Europe work program. But not only, they also monitor overall the progress of the battery sector and the results of the Horizon Europe projects. So BEPA has a key role in shaping the work program, but the calls for proposals remain open to all, even to non-BEPA members. From 2021 to 2027, the Commission will invest more than 925 million euros in battery projects funded under Horizon Europe Cluster 5. CINEA manages all battery calls and projects during their implementation. So BEPA has no role in the selection and the management of the projects that are awarded. However, they follow up closely the projects, and they, of course, contribute to reinforcing the collaboration among the stakeholders and the projects. And on their side, BEPA has also committed to a 925 million investment in battery research and innovation. And the goal in this partnership is to cover all parts of the battery value chain that you see in this circularity loop. So really to cover all the aspects, starting from the mining, processing, and mining, processing of raw materials, and then also by the development of advanced battery grade materials, but also the design and manufacturing of cells, packs, and modules, as well as the application integration, also their end of life through reuse, recycling, or repurposing. More specifically, the application and deployment of batteries is also addressed by other transport partnerships for their applications in their sectors. You see them here in the slide. They are the 2.0 plus partnerships, Europe's Rail, Waterborne, and Clean Aviation. So it is clear that BAT4EU aims to cover the entire value chain. However, they have a higher focus on some aspects that you see with the darker arrows here. And these are specifically the steps that are not covered by the other partnerships, like the transport partnerships. However, BEPA also covers the entire value chain. And I would like to give some key figures about all the BAT4EU projects so far. 34 calls were published. They represent an EU funding of about 518 million euros. And currently there are 74 projects running. They were awarded between 2021 and 2023. And the projects that were awarded in 2024 are about to start or will start very soon. And these projects cover the TRL chain from 3 to 7, meaning from laboratory scale to pilot scale demonstration. So I would like also to put these projects into the context of the Critical Raw Materials Act, as my colleagues have previously presented it. I'd also like to remind the 5 main points that were already mentioned and that are important in this context. So for example, about setting the priorities and to set a list of critical and strategic raw materials. So to complement what my colleague said, I have added here this list of materials, and you see that there are many materials that are relevant for batteries and that are really important for the green and digital transition. And all the benchmarks were already reminded. One of them is, for example, that no more than 65% of the EU's annual consumption for each strategic raw material should come from a single third country. And we see that the challenge is high, as, for example, one statistic shows it, is that 95% of the EU's magnesium supply is sourced from China. So this brings me to the second pillar, which is to reduce the dependence on the supply of external materials and to increase the European capacity in extraction, refining, processing, and recycling. And this will be done by developing exploration programs in the EU, for example, speeding up permitting and creating strategic partnerships. The other key pillar is the third one, which is to improve the resilience towards the disruptions in the supply chains. And then another key pillar, which is particularly relevant for BAT4EU, is to promote more sustainable and circular raw material economy. And many projects address that by developing technologies for recycling, reuse, repurposing in order to develop a strong second market for the reuse of battery materials, cells, packs, and modules. And then a horizontal point is the fifth one, is to invest in research innovation. And this is how Horizon Europe intervenes. because if the technologies are more efficient, we need less raw materials. If we can have efficient recycling technologies, we do not need then to source materials from foreign countries, and we will thereby decrease our dependency, reinforce resilience, and have a more sustainable value chain in batteries. So to illustrate all of that, I would like to mention the projects and the calls that have been developed even before the the Critical Raw Materials Act was enacted, because the stakeholders are well aware of the challenges, and BAT4EU, together with BEPA and the Commission, have developed calls to address these critical challenges in raw materials. And there are specific calls dedicated to that. So, for example, one of them is the sustainable processing, refining, and recycling of new materials. And there are 3 projects there. For example, Anicon addresses recycling routes for nickel and cobalt, while Licorn and Relief are specifically oriented towards lithium recycling. Then we have another group of projects which were awarded under the call Sustainable Processing and Refining of Battery-Grade Graphite, so specifically focused on graphite materials. These projects are Graphorphite and Source. And there are other calls as well, which are oriented towards the manufacturing and production of battery-grade materials. Then there's another group of calls that fall under the category dismantling, recycling, and circularity. So these are classified according to their main focus, but of course, they can also address the entire value chain. So, for example, Respect falls in the category of sustainable, safe, and efficient recycling processes, as it was outlined today, together with its sister projects, Rhinoceros and Free4Lib. Then there is another group of projects that is dedicated to the streamlined collection and reverse logistics, so to create automated and cost-efficient processes to assess the state of X of batteries, to sort them, and to decide whether they can have a second life or if they will go for recycling. So there are many other calls that address this that are also recent. For example, in 2024, a new project will start in January. It's Circobat, which will assess business models to reinforce the resilience and sustainability of the European battery value chain. So I will not list all the calls, but this was more for your reference to give you an overview to show that all the value chain is really covered. Many projects are specifically relevant in the context of the Critical Raw Materials Act. But this is also to show you that in some regards, all the projects will contribute to it, whether it is for recycling or by developing more efficient materials and thereby reducing the need for more materials. They will work towards the objectives of the Act. Another group of projects is specifically dedicated to cell design and manufacturing. You see them here, that it's about the development of next generation of batteries, to have an efficient assembly of these batteries. So again, this is a variety of projects, all of them managed by SNEA under Cluster 5. And in addition to that, specific calls are then dedicated to their integration, even if some of them, when we talk about cell design and assembly, we always try to think of the application in mobility and stationary areas. Some of them are specifically then dedicated to their use, and for example, by developing efficient battery management systems in these applications. And then there are a group of transversal topics and coordination actions that aim, for example, to harmonize the life cycle assessment across projects, to develop and establish a research innovation ecosystem in the battery area, and as well as to coordinate all these projects and foster collaboration among them. So I hope this overview convinced you that the BAT4EU partnership will work towards achieving the objectives of the critical raw materials. And in the concluding remark, trying to answer this question today, is it a dream or a reality? Well, it will have to become a reality. And I hope all these projects will contribute to that. There are currently more than 70 of them running. More of them will work towards these objectives, so we have to follow them closely. And then also to see as an outlook how they can achieve then further scale up. And this is a sort of opening I would like to give to the Innovation Fund, because after demonstrating these technologies at pilot scale, the Horizon Europe results would need to further be upscaled and their solutions brought to the market. And I would like to mention as a final remark that a few days ago, now in December, a new innovation fund calls opened. They're also managed by Cinea. So two specific calls opened. One of them is the regular call. So all battery projects are eligible for it, meaning all proposals that will address the battery value chain. But there is another specific call that was dedicated to electro vehicle battery manufacturing. And well, I hope this will bring a great opportunity to further develop the results achieved under Horizon Europe. Thank you very much for your attention.
Also, we have the pleasure to have Franz Geyer from BMW Group. So Franz is head of the technology and strategy at BMW AG, with an extensive expertise in zero-emission mobility, decarbonization, and sustainable supply chain. He actively drives political and industry initiative and holds key roles, including executive board of the BEPA, also at the CLIP, the Competence Network Lithium-Ion Battery Industry Association in Germany, and in the Emotive. Additionally, he is industry chair at Battery Europe and leads the ACA Task Force on Digital Product Passport and the ECAR Expert Group on Battery Technology. Franz?
Many thanks, Justo, for this introduction and for the invitation, and also Elisabetta for pushing me to have this presentation ready. Many thanks. And also, there's been a lot has already said, so I can speed up in a few topics, I would say, and probably can find a bit more, let's say, perspective of OEM to this regard. And the topic is today specific challenges and strategies, and I would turn it around, starting with the strategies and go to the challenges. And in the introduction, I saw that I forgot the opportunities, of course, but let's give the opportunities as a given, consider them as a given, start from the strategies, go to the challenges, and then talk about the opportunities. First of all, the BMW strategy is very easy for in the baseline. I would say it's electric, circular, and digital, and it may not really hit your eyes at the first moment, but of course, electric is dedicated to the workshop of today on recycling. Circular obviously is really supporting the recycling, but also digital, because this digital is beforehand meant from a customer perspective to have the car on a digital new level, but it's also regarding supply chains being digital and sustainable. And for example, one of the topics is the product passport, which then enables circular economy really to be executed according to the new industrial clean deal. And these three strategic pillars, when it comes to circularity, have ambitious goals in the back. So we would like to have minus 20% of CO2 in the supply chain, minus 80% in the production, and minus 50% in the usage. In total, it's about minus 40% of CO2. The minus 50 is, of course, coming due a higher ratio of electrification. But also the ICE is contributing to a reduction of this, and it will be complemented with fuel cell cars, a small share from 28. And an important thing on this CO2 reduction is that, of course, in our case, it is powered by PPAs to have this reduction. In our point of view, we really put the money into the hands of the profits that are for the energy transition. And this brings us forward to achieve these goals. With average carbon counting, it would not be able. And as already heard today, we will also expand our secondary share. This means we are convinced that secondary material is having a less CO2 footprint. And if we increase this share, we have an additional, let's say, pusher for this topic. Okay, and now back to the cells where we started today. So what we did back in the days when we launched the i3 and the i8, we've started with the NMC 333 technology, and we significantly reduced the rare earth materials with all over the years to NMC 811 on an NMC technology. But we also tried to introduce, and it's let's say it's depending on gear regions, the LFP technology, but for Europe as well, that's a substantial share that we would like to bring to the market. Some may say there's another challenge coming up on recycling, but luckily Justo in this project is caring for LFP as well. And on the other hand, to be resilient, and we've already heard about these supply chain constraints, there's this secondary raw material quote is very important. And firsthand, this is also part of Respect, is the direct recycling, to have the production scrap back to the chain. And luckily, this is considered as a first step of SRQ, because this really helps us to get some tangible targets. And in the second step, and I explained it already this morning, the cars we build and the battery in it is built as a unit to last for its entire life. So it could take some time until they come back to the value chain, but that's good for the customer and for us, providing a reliable product. But it's a bit difficult then for the recycling business. Nevertheless, I think the uptake is the most important topic, and this recycling business also for post-consumer scrap will then feed the appetite. And next to these supply chain constraints, we can really help to have a kind of answer to the fluctuating prices on raw materials on one hand. And there is also something coming out from DG Grow, I think, or Environment early next year on the avoidance of black mass leakage that will also help to sustain our material circular supply chain. And now, last slide from BMW. How do we face these challenges? We started to invest in a so-called battery cell competence center in 2019. This is able to build up cells in the number of 5,000 to 6,000, not limited to a format. It's a coin, pouch, cylindrical, and prismatical cells. And this is really to have on each and every technology a kind of leading edge attitude to really trigger our supply. What we really do here is we take not the batteries out of the shelf, but we try to develop the best to get on battery level with our suppliers to have the best promising requirements met in the product. And this is really also feedback from the suppliers. This is leading edge technology which we are preparing here. And also it's only a few hundred people working there. It's really a big chunk of contribution to the development. And as we are convinced that product and process development needs to go hand in hand, we also invested in a so-called CMCC, Cell Manufacturing Competence Center, which then is, let's say, a scale of 0.1 to 0. Something gigawatt hours per year, but it's not on the amount of energy produced. It's really on deep understanding, even also with AI technologies, on the production processes and the improvements on it to get one of the bottlenecks in our implementation solved, which is the industrial scale. And today I'm really proud, because it's only issued last week, that we closed the loop now also for the so-called CRCC, the Cell Recycling Competence Center, which is urgently needed in this race of, let's say, materials. And the Cell Recycling Competence Center is our way forward, which will approximately be opened around in 26. We are just starting to build it now, to have also leading edge abilities for the cell recycling, as we did with the rest product and process. And I think I don't need to stress this too much. It was already said. This was the BMW perspective, and there's something also supporting all of this mechanism from outside, which is the Innovation Fund just named, the Net Zero Industry Act, the Critical Raw Materials Act, and the TCTF, which is considering the batteries. And we are also really looking forward on the Competitive Fund, which probably brings new money into the mills of our industry to be competitive on a global scale. right now we see these initiatives, but we don't see new money. And this is also a topic which is a bit crucial. It is perfect having all of this, but we really need to have a lever on industrialization. And one of the topics there is, of course, money. And this is why we are looking forward to the competitive fund, dedicated projects, not only in innovation fund, but dedicated projects along the entire value chain to be competitive on a global scale from Europe to Europe. So now back to recycling. What are, from our point of view, the needs? It's not limited to the batteries, it's also for the powertrain itself, like the e-machines. We need a recycling infrastructure which is securing, on one hand, a high quality of recycling for the materials, but on the other hand, also high capacity. Because if you saw the numbers from Justo in the first presentation, we are talking about tons and tons of materials to be recycled. And so we need to have facilities being able to digest all of this, let's say end of life scrap in the end, but also not only digest, but in a high quality. The second thing is we need to have new shredding and milling technologies, because the battery sizes, once you've the time to visit BMW, I can show you a battery, or maybe you've seen some of them already anywhere else. The size of a battery is not too small. It's a substantial part that needs to be shredded. This is one thing. But on the other hand, we need to have the right materials out. So it means the shredding needs to be as good that we get the materials in its best case out again. So it needs to be big, but it needs to be also very to the point to get the materials out. And the third topic is the energy used in this recycling process. We've already learned and probably known before that secondary materials have a smaller footprint compared to virgin ones. But if we make it happen that the recycling business is even more energy effective, this will help on top. It will also help the business case to be more beneficial, and energy costs, of course, will support this as well. For upstream, for example, we need 30 gigawatt hours to produce 1 gigawatt hour of cells. If we could reduce the cost of energy, that would extremely help already. And the same is then for the recycling process, because there are a lot of thermal and chemical processes which are driven by electric power, and therefore the energy costs, if they would be green and cheap, this is an enabler too for us as Europeans. And for the sorting process, it really needs also to be kind of supported with sensors or AI mechanisms to get a good quality of materials out. So in a nutshell, we need to have new, and BEPA probably can help, like Respect Project is a good starting point. We need new processes for the recycling of the entire powertrain and for the relevant materials out of the batteries and e-machines. And we need to really invest in recycling technologies and methodologies, not to have a downcycling, but at least a recycling, or in best case, even upcycling. So, and then the almost last slide, the risk that we face really is to avoid the cars leaving EU. The second risk is to keep the black mass in the country and having the access to this. For the dismantling, we really need to have, let's say, we need to have technologies that are able to dismantle the car and the battery in whole to have a business case on one hand, but also technologies that are able to really digest the appetite, as I just said. For the transport, it was mentioned also, and there are further projects funded by SENEA on the transportation of this topic. We really need to have again, low CO2 emissions, and we need to have ways to transport it safe and efficient to the recycling mines. For the shredding, I just said we need to have machineries which can digest the big, but also come up with a good material grade in the end. For the separation and sorting, we really need to say, how can we improve the quality of the materials coming out and being sorted? For the regain of materials, there are two steps. The one is, of course, utilizing the mechanical and the chemical steps. And in a more detailed, we really need to have new methods and processes to execute this recycling process for all of the materials, not limited to the lithium, nickel, and cobalt. And finally, as just said, we need to have the common goal, which is low energy costs, high energy efficiency, high quality of the processed materials, and of course, carbon footprint that is way lower than the virgin materials. And this is my summary already. Hopefully, it was not too boring. Our conviction is we really first need to import and then recycle because we are not having the materials right now. And import could also mean, as in the Critical Materials Act, having Europe and France be extracting materials to come to Europe, and also emphasizing European mining. But we've seen as well that from a raw material found and until the day it's delivering, there are 17 years in between, and 12 of it are only permission. So import and then recycling is more realistic for now, at least. Then we need to have huge investments in the recycling facilities, and we are convinced that they are quite as high as the one for the upstream technology. Therefore, we are looking really also for the competitive fund. We need a strong need for R&D in recycling, which is Respect already executing today, but probably there's more to come in the future, even also after Horizon Europe. And we need this for all the areas: batteries, power electronics, inverters, e-machines, and we also need to use the added value of digitalization and automation. For example, when it comes to the end-of-life recycling, the battery passport can help really to have a machinery park that adjusts itself according to the battery coming in, and then you can have like multiple batteries being dismantled on a very high quality through digitalization, just as one of the examples. And of course, the regulatory framework was meant a few times today. We really need to focus on the part that is fulfilling the needs from politicians, like the Clean Industrial Deal objectives. But we also need to look at the implementation, and this is the crucial part. The implementation needs to be feasible for the industry. And one voice of the SMEs within Europe regarding the battery regulation, for example, is that they only see a bureaucratic burden without any benefit for themselves. And they rather outsource this technology because they will not be able to come over this regulatory framework to be compliant by their own. And this, you see, is for the SMEs reality. For the OEMs and the big suppliers, it's even also not a walk in the park. It's really hard to overcome this. So the regulatory framework needs to be implemented, that it fulfills political goals, and also not harm the industry, at least support or even accelerate the industry. And we also need to really look at regulatory frameworks that are meant for environment and meant for competition. I think these are two different ways. It could be that there's some competitive share in the environment, but we really need to be true to ourselves, what needs to be done to be competitive in a global scale. And if we would like to have these factories for recycling, for upstream and so on, we need to have skills, not only the R&D skills, but also the blue-collar workers to drive the factories. That's it in a nutshell. Thanks a lot.
For this interesting point of view from the car makers. So I will introduce Antoine Driancourt that will present us some insight again from the Respect project. So Antoine is a French engineer at the CA, specializing in lithium-ion battery recycling, with a master in energy system from the MIT Atlantic in France. IMT, sorry. It's the same. He has led initiative in recycling alternative energy technologies. Currently, he coordinates European projects like Respect and Batro, focusing on advancing sustainable energy storage and promoting the circular economy.
Thank you, Justo, for the introduction. So I should move to the next. So within the next 15-20 minutes, I will try to show you and explain you how the last results of the Respect project can bring some interesting insights with regard to the current EU Battery Directive and Critical Raw Materials Act. So it might be the most technical presentation of today, so I hope you're ready. Just to come back. So Justo has already introduced the project, but I wanted to come back on the technical concept we want to demonstrate in the Respect project. We really want to develop the complete battery recycling process, covering all the process steps of the value chain, and we want to bring innovation at each of these process step. It starts with the deactivation of end-of-life battery modules. We are quite convinced that the current state-of-the-art technologies will have big challenges and difficulties in the future to discharge all the diversity of modules available on the market, and we try here to bring a solution on this. Second important point is the pretreatment part. Usually we have a lot of intensive crushing and thermal treatment approaches to do the pretreatment of batteries once they are discharged. Here we try to avoid as much as possible the use of thermal treatment approaches and crushing to allow already a good separation of the different components contained in the batteries at this pretreatment level. So we managed to separate copper, aluminium, binder, lithium, and we have two main output fractions, which is a fraction containing graphite and a second fraction containing mostly cathode active materials, which can be mostly NMC or LFP depending on the input material. For the graphite, we have then one partner, Vianode, located in Norway, who is responsible for the regeneration of this fraction for then reuse as new anode materials. Regarding the treatment of the cathode active materials fraction that we could call also black mass, we have two different routes here. The first one is the low impact hydrometallurgical treatment. So we will put into solution the metals contained in this fraction, and then we will do some separation to produce battery grade sulfate salts that then can be reused to produce new cathode active materials. There is an alternative route to valorize this cathode active materials fraction, which is the direct recycling. And here we try to avoid to put into solution we work to demonstrate the different technologies is that academical partners and universities determine operating conditions for the different process steps. And then we have, for all of these process steps, a pilot equipment at the site of one of these or our industrial partner that allows us to demonstrate the technologies on real input material. I will quickly come back to the recovery targets that are set in the project. So our project will end in 2026, and we target to recover around 95% of cobalt, manganese, nickel, 90% of graphite, and 75% of lithium. For the cobalt and nickel, these targets are close to the one from the EU Battery Directive for 2031. Same for lithium. And for the graphite, there is currently today no recovery target that is set in the legislation. So the results of Respect at the end of the project will give a good feedback on the feasibility or not of the future targets for 2031. I will now bring to you three main messages at different stage of the recycling process. The first message learning is about the recovery of high quality graphite during the pretreatment. Last results have shown that this is possible to recover a really high quality graphite fraction quite early in the process. And this is quite a good news for Europe because we have seen during the presentation of Maria that there was only 3% of graphite that comes from a recycled source in Europe. For battery application, it's probably even lower. So graphite source from battery recycling processes could be potentially used in the future to supply the needs for anode materials in Europe. Where does this affirmation come from? So we have performed two pilot tests in the project. The first one was a pilot test on production waste, anode production waste provided by the cell manufacturer involved in the project, Moro. So we received 15 kilos of this fraction. You have a rough idea of the material composition, so around 65% of carbon content and 28% of copper from the copper foil. We have applied the process developed in the RESPECT project, and we managed to separate a really high quality of graphite with this single process step separation with more than 99% of graphite content. Some samples of this fraction have been then sent to Vianode, and Vianode is currently doing some characterization of this fraction to validate that this can be reused for the manufacturing of new anode materials. The first feedback are really promising, and Vianode is convinced that this graphite source can be used to produce new anode materials. The second test that has been conducted is related to a more complex waste stream, which is end-of-life battery. As I said, we have developed a new approach to get access to the active materials contained in batteries. So here is the result of a test conducted on a discharged BMW E3 module. Orano has performed on its site a first process step developed in the project to extract, without crushing and without thermal treatment, the electrodes contained in the module. So we managed to get access to around 15 kilos of this electrode. And then a second step was applied to start a first separation of graphite and cathode active materials, are also performed by Orano. Two main fractions are the output of this process. The first one at the top is the cathode active material fraction. You have a rough idea of the material composition also, with only 12% of carbon content in this fraction, which is way lower than the content we find in conventional black mass. In conventional black mass, you find more 40 to 50% of carbon content. The second fraction is the graphite fraction, with around 65% of carbon content and some residual impurities with around 20 to 30% of metallic impurities. Some samples of this graphite fraction have also been sent to Norway to Vianode to check if the quality is okay for reuse as anode materials in the future. First feedback is also quite positive. And as I said earlier, these results are good news for Europe about the possibility to recycle graphite in the future. We don't talk about the economics now, but it could be a subject for the panel discussion. But at least from a technical point of view, it seems feasible to recover high quality graphite from batteries. Second message of today is related to the next part of the recycling process, so the low impact hydrometallurgical treatment. Here we have demonstrated that we managed to produce high quality leachate that can be used to produce battery grade salts. However, we have observed some significant losses in the pilot test that was conducted, and we need to keep that in mind for the future. Here are the results of the test that has been conducted. So in terms of organization for this hydrometallurgical part, all the operating conditions have been determined by Aalto University in Finland and Chalmers University. And then the company Mezzo has a pilot line for hydrometallurgical treatment in Finland for the three first process steps of the hydrometallurgical treatment. And a pilot test was performed in Finland for these three process steps: the leaching, the copper separation, and the aluminum and iron impurity removal. The input material for this test was 100 kilo of black mass that was produced by Orano. So you also have here an idea of the composition of this black mass with low amount of impurities compared to standard black mass, only 0.5% of aluminum. What is interesting here is to see what are the different losses for the the most interesting metals contained in the black mass at each of these process steps. And if we check for nickel and cobalt with this test, we have more than 5% of losses, around 7% for nickel and 5.5% for the cobalt. So with regard to the targets of the EU Battery Directive in 2031, with 95% of recovery for nickel and cobalt, for this test, we don't manage to reach this 95%. Good news is that we reached the 90%, which is set in the legislation for 2027. But the 95% might be challenging in the future for recyclers. Of course, it is only a first pilot test result. We still have 2 years in the project to further optimize the process and improve this recovery and reduce the losses in the hydrometallurgical process. However, I think it's important to keep this dialogue between recyclers, policymakers about the feasibility of the targets that are set in the legislation. And to finish and conclude, last key message now on another part of the process, the direct recycling one. It's not directly related to the achievement of the recovery targets from the EU, but direct recycling is a fascinating topic, and I thought it's a good opportunity to discuss this. So the message was direct recycling opportunity to secure cathode active materials in Europe or not. Just one slide to reintroduce the concept of direct recycling. So the idea is to say that in black mass, we have a lot of intact cathode active materials. Can we find a way to directly reuse these cathode active materials contained in this black mass and avoid all the process steps of the hydrometallurgical treatment? From a theoretical and utopical point of view, if we manage to do so, we could have less process steps than in the hydrometallurgical treatment. If we have less process steps, we could also imagine to have lower cost with direct recycling approach. And if we have lower costs, it could be also a way for Europe to have solution to recycle low-cost chemistries such as LFP, where current hydrometallurgical treatment technologies will have some challenges to propose a competitive solution. Last point is also quite critical for hydrometallurgical treatment is the amount of wastewater generated. With direct recycling and process with less intensive in water, we could have also a decrease of the amount of wastewater needed for the process. Also, another remark more related to the critical materials aspect. If we manage to do direct recycling, it means that we will manage to have directly an output which is cathode active materials. And it means we are already a bit higher in the value chain than with the output of a standard hydrometallurgical process where we will produce battery grade salts. And I remember a discussion with Franz during one of the advisory board meeting of the RESPECT project, saying that it's challenging today for some of the OEMs to secure LFP from China due to some tensions. If we have a solution with direct recycling to directly produce directly recycled LFP, it could also help from a supply point of view the European Union. Quick conclusion on the 3 messages that were mentioned in the presentation. So if we come back to graphite, we have shown within the first 2 years of the project that with innovation in pretreatment, we managed to separate graphite early in the process. The ongoing quality check, but this is good news for Europe, and we could maybe try to promote a bit more this graphite recycling to limit our dependency to China for the supply of battery-grade graphite. Regarding the hydrometallurgical treatment, high purity leachate production is possible, and we will manage to have battery-grade sulfate salts in Europe. However, we should not underestimate the amount of losses that could be generated in the process. The results I've shown are only for 3 of the process steps, but in the battery recycling process, we have in total more than 20, 30 process steps. So we could have also some additional losses all over the value chain. And regarding the direct recycling part, well, some work is necessary to further purify this material, but it is definitely for Europe a topic which is interesting and attractive, and we should promote even more this direct recycling approach. And if in the future we manage to reach good performance with directly recycled CAM, it could help us to reduce our dependency to the import of cathode active materials from other countries. Thank you very much, and thank you to all the RESPECT partners for their input and contribution to this presentation. Thank you.
Thank you, Antoine. Yeah. Okay, so now, I'm pleased to introduce you. So Enrique Moliner from Lomartov, which presents us the current state of play of the lithium battery, the impact on health, environment, safety, and circular economy, new practice related to developed processes. So Enrique is a senior sustainable technologist at Lomartov, which is a PhD in industrial engineering. He has 18 years of experience in sustainability and circular economy, specializing in eco-design, life cycle sustainability assessment, and circular economy modeling. Moliner support a company and R&D organization in developing a sustainable solution and has conducted the LCA in over 30 EU-funded projects, including those focuses on energy storage. Please.
Thank you, Justo, for the nice introduction. Yes. Yes, so I'm Enrique Moliner from Lomartov, an environmental consultant company in Spain. And in this RESPECT project, we are coordinating the work package on sustainability. So we're aiming this work package is to demonstrate and optimize the life cycle sustainability and also the safety of the RESPECT recycling process. So we are working on environmental LCA, economic life cycle costing, and social life cycle assessment. And we are also performing a task on chemical risk assessment. So we are in line with the Safe and Sustainable by Design framework established by the European Commission. And for the validation of our recycling process, we also need a baseline against to which compare our sustainability and safety impacts. And this baseline scenario is given by the current treatments or the current end-of-life routes for the lithium batteries. And we are currently working on the life cycle sustainability assessment of the recycling process developing RESPECT. But during the first period of the project, what we did was to calculate the environmental, economic, and social impacts of this baseline of these conventional technologies. We use LCA, LCC, and social LCA to assess up to 54 scenarios, which were the result of combining 2 battery chemistries. We consider LFP and NMC 111. We also consider that these end-of-life batteries could be generated in different regions of Europe. So we consider Spain as representative of the Southern Europe region, Germany for the Central Europe, and Sweden for the Northern Europe region. And we consider that today these batteries can be treated following 2 main routes. That would be the hydrometallurgical and the pyrometallurgical one. We did not consider the direct recycling because it's still under development and not a reality today. And we also consider different destinations for the waste according to the location of the recycling plants. So we consider different locations in Europe. We try to look for the location closer to the battery waste origin. And we also consider recycling plants outside Europe, like in USA and China, to see or to compare what happens when recycling inside Europe or when recycling abroad. And all the recycling plants that we consider are current existing plants. According to the literature, we consider the characteristics and their throughput to also check how the plant capacity could affect the impacts or the sustainability, especially from the economic perspective. We performed assessments for a functional unit of 1 ton of battery packs treat. So we have this common basis to compare the impacts among the different scenarios we are investigating. And in the assessment, we include from the battery pack collection through the disassembly, where we already obtained some materials to be recovered, like the plastics or metals from the casing and other structural components. Through the disassembly, we obtained the battery cells, and we consider two options here. The battery cells could be directly delivered for pyrometallurgy, but they can also be pre-treated to obtain black mass that can be treated either by pyro or by hydrometallurgy. These are the results for the environmental LCA study of the baseline scenarios. And what we can find, for instance, is on the bottom you have the results for NMC recycling. You have the direct impacts of the process on the right side of the graphs, and then we have on the left side the avoided impacts. As we are obtaining secondary raw materials, this will avoid the primary production of these materials, of the nickel, the cobalt, the lithium, and this provides huge environmental benefits because they are really energy-intensive materials for primary production. So they completely offset the direct impacts from the recycling process. And the same happens even with lower avoided impacts because we are not recovering so interesting materials like in the NMC, but we still have environmental benefits in the LFP recycling that offset the direct impacts from this process, either for hydro and pyrometallurgy. So the first conclusion is that all the processes we are and all the scenarios we have investigated could be environmentally feasible because the recycling has lower impact than the production of the primary raw materials. The situation is not so clear for the economic feasibility. Again, what we find is that the recycling of NMC provides higher revenues because of the value of nickel, cobalt, also the lithium, while in the LFP recycling, the incomes or the revenues are more limited. And another finding which was expected is that the recycling in China is more profitable because they have lower direct costs because of cheaper labor force, but also because the recycling plants existing there has higher capacity. And as I will show you later, the economic costs are directly related to the plant throughput. This is why for China we have a lot of profitable scenarios. Indeed, for LFP, I think that only in China we found profitable scenarios. While for the NMC, we can find also profitable scenarios in Europe or in USA, but they largely depend on this throughput I mentioned. Indeed, in Spain, we have profitability in Europe, we have profitability for the Southern Europe region because the plant that we consider there has higher capacity than in the other regions of Europe. And this is what you can find here. Obviously, these are direct costs, only the direct cost broken down by the different elements, the CapEx or the different OpEx elements like labor force, utilities, indirect costs, and so on. And first finding is that the CapEx is really important in this kind of processes because the investment on high technology. And in the case of China, as I mentioned, you can find that they have really plants with really high capacity, like 40,000 tons per year for the pyrolysis or 30,000 tons per year for the hydrolysis. And this is one of the reasons that the CapEx is diluted among these very big production capacities. But if you take a look at some of the European scenarios, we also have high capacity for pyrolysis, for instance, and this is why the cost of the recycling in these scenarios are comparable to those in China. And as I mentioned before, we have one scenario for NMC recycling in Europe, which is profitable, and this is because we have the highest production capacity there, which is around 7,000 tons per year. So this would be more or less the break-even point from which recycling, NMC recycling using a hydrometallurgy seems feasible from an economical perspective. And finally, we have also investigated the social impacts of these value chains. We have only included here the impacts for those scenarios that were demonstrated as economically feasible. And what we can find here is that for the NMC, the recycling of the batteries provide huge environmental benefits, especially coming from the cobalt and from the nickel, because we are avoiding the primary production in countries where social conditions are not really good. They come from Africa or Asia, and yeah, the situation there is not good from a social perspective, working conditions, health and safety at work, and other aspects that are considered within this social LCA. And then on the left graph, we can also find the direct social impacts of the recycling. These are the blue bars on the right side. And what you can find there is that the recycling in Europe, the direct impacts are much lower than when recycling in China. Again, because the social conditions here are better than there. Finally, we also consider the LFP recycling in China, and in this case, as from the LFP, we are not recovering these critical raw materials like the nickel and the cobalt, but only the lithium. The benefits are not so large, and they do not completely offset the direct social impacts from recycling in China. And on the right side, you have another graph where what we are doing there is to compare the social impacts of the chemical sector in these different regions in Europe, China, and USA. And this is the reason why the direct impacts are much lower, direct social impacts are much lower in Europe than in China. As you can find, the production in China has like from 7 to 9 times the impacts that can have the production in Europe, which is even lower than in terms of social performance than in USA. So some remarks to conclude. NMC recycling brings more sustainability benefits than the LFP recycling, as we find as the initial finding. And the net environmental benefits were found for all the scenarios investigated, meaning that the recycling of the batteries has lower impacts than the primary production of the materials in these batteries. And we found that recycling inside Europe showed the largest environmental benefits due to shorter transport distances, but also because of the energy mix, which has more renewable content here than in China or USA. And the hydrometallurgical route provides in general larger profits than pyrometallurgical, which was only profitable for NMC. And NMC can be economically feasible in all geographies, especially in China, because the lower cost for labor that we mentioned. But this profitability will depend especially on the plant capacity. So in Europe, we found that NMC recycling can be feasible from 7,000 tons per year. And the social impacts were the largest in China and the lowest in Europe. And most of these benefits, both environmental, economic, and especially social, are due to the recovery of these critical raw materials, especially the cobalt and the nickel, which are expensive materials, high energy intensive materials, but especially the mining and processing conditions of these materials in their countries of origin has associated very large social impacts. And so maybe the economic issue is the main challenge, but when we compare the environmental and social conditions of recycling in Europe compared to exporting the materials to be recycled abroad, it is clear that these are clear arguments that this is something that works, and together with the need to decouple from the obtention of critical raw materials from outside Europe.
So now I will introduce you to Guillaume Barbe. Guillaume Barbe is a project manager at Seva Logistics, specializing in reverse logistics for battery to support the circular economy of electric vehicles. He holds an engineering degree from ICAM, the School of Engineering in France, and started his career in Slovakia, focusing on industrial performance in the automotive plant. He later worked at JEFCO as a workshop project manager, leading the development of electric vehicle charging station. Since 2022, he has been managing projects related to the logistic end of the end-of-life batteries.
Thank you very much, Justo. So yes, indeed, my name is Guillaume Barbe, and I'm a Battery Logistics Center project manager at Seva Logistics. And today, I'm really pleased to present you what are the challenges to create an optimized logistics for the end-of-life battery. So my presentation will be divided in 3 sections. First, we will see how the battery regulation contributes to the achievement of the CRM objectives. Then we will see what are the challenges to create an optimized logistics for end-of-life batteries. And finally, we will see how we can face these different challenges. So first one, so the battery regulation, which was published in 2023, provide the frameworks by imposing the collection of the batteries, by imposing recycling a quantity of recycled material in the production of the new batteries, and finally by imposing a target of recycling efficiency. So this attempts contributes to the achievement of one of the CRM objectives, which is to ensure that the recycling capacity of European covers at least 25% of its strategic raw materials consumption. And we can see here some example of strategic raw materials that we can find on the batteries. So what are the challenges? We identified 3 main challenges for the logistics. So the safety, the legislation, and the market maturity. The safety first. So what is the links between these different pictures? I think it's quite obvious. This is the fire. And we know that with the batteries comes the fire risk. And these 3 accidents that you can see on the pictures happened this year in 2024. So this is not something theoretical, this is something real that's happened in real life. And the consequences of that is massive, significant material losses, and even in the case of Aricel, the death of 23 people. So this is something real, this is something huge, and we have to make all that we can to reduce the risk. The second challenge is the legislation. So today, the situation in European Union, we can see here on this map, this is a non-harmonized situation between the different countries on the waste status. For instance, in Spain or in Portugal, sorry, batteries are considered as hazardous waste, when in Belgium is considered as non-hazardous waste. So it's due to the lack of one European waste code dedicated to the lithium-based batteries. So this leads to some unclarity and uncertainty among the different stakeholders. Hopefully, this situation will change in the coming months with the law modification, which will create a new and dedicated European waste code for the lithium batteries. You can see here the code. So it will lead to an harmonized situation, and all the European countries will have to follow this code. This is the good news, but it's also a bad news for the logistic company, because this code is considered, the batteries are considered as hazardous waste with this code. And with hazardous waste comes more stricter regulation rules. And for instance, on the storage, we will have to upgrade of our environmental permits to obtain the agreement to store hazardous waste. And this kind of agreement are difficult to obtain and take long time to obtain as well. And we can see on the table, for example, in France, it can last up to 18 months to get the agreement. So this is a significant constraint for the logistician. And as well, on the transportation, we had an issue with the hazardous waste, because when we do cross-border transportation, we have to do what we call a notification, which is an administrative procedure that we have to do between the countries, and this is something quite complex and more complex than a simple information procedure that we have to do when we are dealing with non-hazardous waste. So it adds also complexity on the transportation, and especially for the cross-border transportation. And aside of the constraint on the waste statuses, whatever the statute of the battery is, it can be waste, it can be product, we have to deal with the ADR regulation for the road transportation, because batteries are considered as dangerous goods. So this point adds a constraint for the logistician as well, because we have to find ADR capabilities, which today are sometimes quite difficult to find on the market. The final challenge we identify is the market itself. There is two big aspects. The first aspect is the volumes. Oh, sorry. The volumes. And the second is the geographical footprint of the collection points. Let's have a look on the volumes. If we look at the chart, which is a forecast of the growing market of electric vehicles in the coming years. So on the x-axis, we have the years. So it's come from 2022 to 2035. And on the y-axis, we have the percentage of the market share of electric vehicles in Europe. And we have two curves. The first one is the forecast of last year, 2023. And on the red curve is the upgraded forecast of this year. And we can see here, there is a big gap between the two forecasts. So what I mean is, even for the new batteries, for the new vehicles, we have unforeseen forecast with a big gap. We have more than 20% of difference between these two curves. So we can imagine that if we want to have figures on used batteries that we have to collect it, we will have to add the uncertainty of the battery lifespan. So it will add complexity and uncertainty. So today, it's really complicated for us to have accurate and reliable forecast of where and when we will have to collect the batteries. So this is a challenge for the logistician company. And the second point is the geographical footprint of the batteries, of the collection points. So as the market is not mature today, I took the assumption that we will have to collect the battery at the current selling points that we found in Europe. So selling points today are mainly the dealership. And this is the point of the battery regulation because it's imposed to the producer, so mainly the car maker, to ensure the collection of the end-of-life batteries. So we think it will be done in the dealership. And for instance, in France, we have more than 13,000 points of sales in France. So if we transpose these figures to the at European level, at European scale, there are more than 1,000 collection points around Europe. So we have low volumes today, unforeseen, and with a geographical spread of collection points around Europe. This makes things complicated for logistics. So these challenges can lead to a lack of compliant logistic means, especially on the storage with the hazardous waste constraints we see with the duration of the administrative procedure. On the transportation, we will have to find ADR capabilities, which today can be difficult to find. And combined with this logistic, the lack of compliant logistic means, we have this unforeseen low and spread and geographically spread volumes to deal with. So these constraints can lead to an expensive logistics, which is away from the automotive standards. And stakeholders want to have the same prices and same cost as they find today on the current spare parts. So how we can face these different challenges? First, there is 4 points. First, on the safety, what we advise a logistic company is to create small storage area to mitigate, to reduce the fire risk, to improve the detection of the fire in this facilities. And we also advise to work closely with the insurer and the local authorities to get all the agreements. On the legislation aspect, of course, as logistic companies, we can change the rules, but we think that it will be easier to handle if the government push to digitalize and to harmonize the different administrative procedures that we have, such as the notification procedure. And things that it will really important is that the logistic company creates or develop an expertise on this legislation, regulation constraints, and specifically on the hazardous waste constraints, because this is something that can differ between the different countries. It's not harmonized. So within project, we created a guideline to help shippers to ship their battery. So it's resume the different regulation that they have to follow, such as the ADR for the transport road and the MDG for the sea transport and so on. And it also give good practice for the storage and for the battery handling. And finally, the market, this is something, of course, that we can change. So we will have to take it as an input data and adapt ourselves. And we think that the best answer regarding logistics is to provide smart, efficient network of collection points all around Europe, and to work country by country to avoid as much as possible the cross-border transportation, which comes with some constraints, some regulation constraints. So to conclude, the battery regulation helps to achieve the CRMA objectives. There are several challenges on safety, legislation, and market maturity to create an optimized logistics that follow the automotive standards. And the logistic company will have to adapt and find a smart solution to deal with the market constraints today. Thank you for your attention.
Okay, so we'll continue this event. So now we'll have a presentation from Fabrice Tassin. So about the role of the BAT for EU partnership and the BEPA in supporting through innovation the ambition of the CRMA. So Fabrice, with a PhD in chemistry and materials science and an MBA, has extensive experience in clean energy and mobility technologies. He joined Umicore in 2008 and focused on electromobility projects, including batteries and hydrogen technologies. He was instrumental in developing and managing EMRE until 2018. Fabrice promotes decarbonization through batteries, hydrogen and recycling. He also coordinates Umicore Asian affairs and since 2024 serves as a part-time Secretary General of BEPA, so supporting the EU R&D partnership on batteries. Fabrice?
So I'm normally scheduled for 20 minutes, but I'll try to do it in earlier so that we can have a nice panel discussion. So I think that most of you are quite familiar with BAT4EU and BEPA, but you never know, so I'm going to rant again, at least telling you about these two acronyms so that we are having the same baseline. So BAT4EU, this is the name of the battery partnership that has been set up thanks to the European Commission in 2021. So BAT4EU, in a way, this is, if you want to call it like that, the instrument that channels the money to collaborative research. And since this is what used to be called in the past the public-private partnership, now it's called the co-program partnership, but public-private means that there needs to be a private part. Is it okay with the mic? Yeah. That means that the private part, this is a non-profit association established in Brussels under Belgian law, which is called BEPA. And BEPA stands for Batteries European Partnership Association. So BAT4EU, the name of the partnership, BEPA, the name of the private part that works with the Commission to run BEPA, to run BAT4EU, sorry. So I think that we covered that slide. What is important maybe to keep an eye on is that on the side of BEPA, it's a growing open family. So everyone is of course free to join the club. there's a small membership fee to pay. This is typical of a club. And we have now more than 230 members coming from different parts of Europe, from different parts of the value chain, research organizations, academics, big, small, medium-sized companies. Recently we had a very nice event in Barcelona, where if you see the pictures, you can see the family feeling that we try to cultivate. Maybe what is also important for you to know is that the European Commission is putting money on the table, and we have a commitment to at least bring the same amount of money on the table through in-kind additional activities, and we are quite successful with that. The vision and the objectives, it would be a bit ambitious to say that we are the only one that want to push for that, but so we are simply contributing to that. And what we want, like everyone here in the room, is a competitive and sustainable battery value chain for Europe, covering, of course, mobility, but also not forgetting that there's a nice application for batteries, which is also stationary energy storage, obviously. And we do that with three main objectives. The first one is to develop technologies which are differentiating themselves to be able to compete. And we do that in battery materials, the cell, but also the manufacturing processes and the battery recycling. Today, we're talking about the raw materials and the recycling. What you can see on the right, this is the circular battery value chain. The more green it is, the more active we are. That's as simple as that. So we are quite active on the top right part, which is the raw materials, not covering the mining, but the refining of them. Then we move to the advanced materials. Then we have the battery cells. And on what follows, which are the module pack and the integration into the application, this is where we are less active. Why? Because there are other partnerships which are, of course, set up by the Commission, and that can work on these elements as well. And then at the end, we have, of course, the recycling activities. The two last objectives, I would say, is to accelerate innovation. And I think that's very important that we stress that element, because we are not alone. We are competing with big economic powerhouses, which have a stronger spending on R&D, much stronger than we have in Europe. And so we need to catch up. It's not going to be easy, but that's what we aim to do. And we want to catch up by developing solutions for the mobility, but also for modernizing and having a greener grid, which requires batteries. So 925 million euro, this is a lot of money, but if you start spreading it over a couple of years, over the value chain, over different topics, you realize that we have to best use the taxpayers' money. And this is the reason why, and this is the rationale why we set up on a regular basis a SRIA, which is Brussels language for Strategic Research and Innovation Agenda. So basically, this is a document that tells policymakers and member states and EU where the industry and the research organizations we believe money should be flowing to in terms of priorities. This is not something that is cooked up by 4 or 5 people in a small office in Brussels. This has been a very bottom-up exercise driven by, I think, hundreds of contributions, started outside of BEPA in the frame of Batteries Europe via a roadmap, which is then later distilled into a SRIA, which is the document that you can have access to if you scan the QR code. Okay, that was maybe the general part. Now, maybe looking at how via the SRIA we aim to support the raw materials and the recycling. And I just have a list of elements that you can see on the SRIA if you download it. These are future topics that we would like to be addressed in Europe. The first one, this is about the sustainable processing and the refining of battery-grade raw materials for lithium-ion batteries. I don't think I need to do this audience to explain why this is important. It would be a bit of a repeat. But you know the objective that we have at the level of the Critical Raw Materials Act. You know how the geographic breakdown looks like. There's a lot of red on the right part of the picture. That means that, of course, via technology and innovation, we need to get better at recovery and refining of these materials. And there's also, of course, the fact that we also want to do this in a sustainable way, because it's not just about making the raw materials available, but that's also to make sure that they qualify not in terms of quantity, but also in terms of quantity. And this is the reason why it has to be done in a sustainable way. What I also want to stress is that we are also looking a bit forward, maybe faster than the battery regulation. We are really, innovators. They look always a bit into the future. We also want to have the same kind of attention paid to the recovery, to the processing, and the refining of the materials that go into the sodium-ion batteries. It's another kind of chemistry which is not at the level of NMC or LFP. It's not maybe for the same applications, but we believe that these batteries, when they reach the end of life, of course, they will have also to be treated in the right way. The other strategic action that we also have in the SRIA, this is about graphite. I think it will speak to the colleagues from Vinode. It's actually some part of the raw materials where we are extremely exposed to any things happening on graphite. And there we want to be able to see if we could not look at the bio-based raw materials to actually come to the level of having graphite more readily available at the right quality for battery applications in Europe. Integration of secondary raw materials, what do we mean by that? We mean that there are lots of tailings existing all across Europe. These tailings, they contain stuff that may not have a lot of value, but they also contain stuff that has value. And we believe that we need to be able to tap into these tailings or other production scrap to be able to recover what we can recover. This is from the Enicon project that you can also check online, where we also want to be able to tap into this extra source of raw materials. And how does it look like? If you go back to the SRIA, you will see that these four initiatives or strategic actions, how you call them, they are placed in time and they will be proposed in the future to the European Commission and the member states to assess the appetite and willingness to direct some funding towards these proposed activities. Of course, we are not forgetting battery recycling. And there, the big topic that is, of course, on everyone's mind is to be able to have recycling processes that are more adaptable, more flexible, more robust to various types of streams coming in terms of chemistry, but also in terms of forms and terms of size. This is what we want to do. Also, I think this slide, I've seen it a couple of times today already. It's all the targets that we have on this very ambitious timeline. We believe that technology has to help, and maybe technology can even help us to have even more ambitious targets, because this can be a differentiator when competing. Also, I don't have to tell you that the battery chemistry mix is not frozen. It's slowly but steadily evolving, and we need to recognize that with the development of the technologies that we cook in the labs in Europe. So we will have to be able to treat a very diversified stream of battery waste in the future, and this is what we want to be able to do with the coals. The last one, this is really for emerging chemistries. Whenever you talk about a new chemistry, there's always someone in the room telling you, but how are you going to recycle it? So I think that we need to think a bit ahead. We will have solid-state batteries at some point. We have to be ready for a new exotic chemistry that could be revolutionary. And this is what we want to be able to do with innovation. And this is usually how innovators think. And so this is how they fit on the SRIA. And last but not least, maybe more transversal actions, if I may say. You know that the battery passport is something that is very important for Europe to be able to document and to monitor and track that the targets are reached and that there is not greenwashing, but that's the reality of it. So there's also been some support in the future that we would like to have towards the battery passport. And then the last, but I think very important topic, it's about life cycle analysis. We have to be able to always support with life cycle analysis whatever we say. Otherwise, we can say a lot of things, but is it really true? Nobody knows. So developing these methodologies in Europe is also very important for us. And that's why you can see that they are also well covered in the SRIA that we have prepared. Of course, the SRIA is not biblical by nature, so it is supposed to evolve over time. So in the course of 25, we will be slowly gearing up to prepare a new version of the SRIA. And my call to you is that if after downloading the SRIA, unless you already have it on your desk, but after downloading the SRIA, if you would see things that you believe are not sufficiently covered, are not well covered, you should feel free to reach to us via the email and tell us your feeling, because this is really community building of a document that has to be useful for you. So we are always looking for your input and your feedback. And thank you. Yes, so now I think that we have to call some of the people on stage because I have to moderate this panel session. So I'm going to be calling, I'm going to be calling Johan first from the European Commission, Policy Officer Clean Energy Transitions at DG RTD, so cluster 5 for those. I didn't have any seating plan, so Justo Garcia, that has been the master of ceremony until now, so he's the head of financing strategy for battery recycling projects at Orano, that you know very well. Franz Geyer from BMW, head of the technology zero emission. Andreas Forgang from Vianode is the VP for sustainability and public affairs. And then we have Antoine Driocourt from CEA. He's the project manager. He's been telling us a lot already today about respect. Enrique Moliner Santisteve, sorry for the mistake, is the senior sustainability technologist at Lomartov. And then Guillaume Barbet from Seva Logistics project manager. So I realize the gender balance is maybe not as strong suit today, but we'll get better next year. I don't know if I... Okay, it's good that you corrected to compensate. Okay, so I don't have a timer next to me, so Elisabetta, if you see that we are going off track, please be very severe with us. The way I would propose to structure the panel is to ask each of you the same question. It may sound boring, but I just wanted to have an opening question to a bit understand your position, because we have the Commission, we have different industrial players from different parts of the value chain, we have the RTO, so I think it may be interesting to hear about you. And then we will dive into a specific question. But my first question is that you have seen the EU battery regulation slide many times today, so it's a very nice timeline with lots of ambitious targets on different types of KPIs. I think this is the way to go if we want to, of course, give an impetus to drive the construction of a battery recycling industry. It may not be sufficient, but there will be a question on that later. What I would like to understand from each of you, and I will start, of course, from the left, and then we will give Johan the opportunity to maybe build on that or give a few reflections, is if you look at all these targets, which one do you believe is very ambitious or too ambitious? And how do you see technology and innovation helping us to get there? So, because today we are very much technology driven in this panel and in this presentation, so technology can help, but of course technology is further developed. And if, I will start with Guillaume, if there is one ambitious KPI that you believe is very ambitious and that technology can really help get to.
Thank you. So on my side, I think that in the battery regulations, the battery passport will be something really ambitious to accomplish, as there is several stakeholders among the value chain that are involved in that battery passport. This is hopefully, I think it's something great because it will ease the traceability of the battery among the supply chain. but as there is many information to be shared, many stakeholders that will have to be included in the creation of the battery passport, it will make it quite ambitious to accomplish. But I think this is a good news and good things, and it will help the traceability and the logistic of the battery.
Yes, sure. Well, I think that the material recovery targets are quite ambitious, but I'm pretty sure that my colleagues will talk about it. So I would say also the digital passport and also one challenge that is coming soon, which is the carbon footprint declarations. And yeah, this might be something easier for big players, but for small players might be something difficult. And I assume that technology can contribute, especially digitalization technologies, Internet of Things, monitoring, sensoring, big data analytics, and so on. But yet this can be, as I said, easier for large companies. For small players, maybe they need some support. And so in some of the previous presentations, some colleagues talk about the skills. So we need the skills not only for the sustainability issue, for the carbon footprinting, but also to deal with this new digitalization technology. So I think that capacity building, training programs, and these kind of things will be a key to be success on this. Yeah, it is.
Can you hear me? Yeah. So on my side, I think so I will do a comparison of the EU battery directive with the WE directive on the recycling of photovoltaic modules. So today there is a recovery target for photovoltaic module around 85%, so quite high value, but there is no specific target for silicon. And in the last 10 years in Europe, there was absolutely no recycling of silicon metal. So it shows that in the battery recycling, in the battery directive, this combination of average efficiency target and to fix a target for specific metals definitely makes sense and will help to recover these specific metals. The targets are quite ambitious. We have seen in the presentation today that we may have some losses in the hydrometallurgical treatment. I think it's really important to bring some innovation in the pretreatment to reduce the amount of impurities of black mass entering the hydrometallurgical process. And this would lead to a reduction of the losses in the process.
For the targets, if one of the metal would be for you the main pain point, which metal would it be?
Nickel and cobalt, I think.
Nickel and cobalt.
To me, no target is too ambitious. I think it's ambitious, the whole battery regulation, but it should be. To pick out one, I have to echo Enrique and Guillaume. That's the battery passport. It's very ambitious, but to me, mainly because there are some challenges in sharing information throughout the value chain that needs to be overcome, and that has to be overcome by industry partnerships, which is going to be quite tricky. And I know there's work going on there, but that's challenging.
Yeah, I can, of course, from my ACEA head or task force leader, digital product passport, I can comment to this, but I would take this on a more broader picture. For me, the main challenge to overcome is really the successful implementation of the regulation, meaning that all parts of the value chains are really, let's say, contributing to achieve the political goals, but also to really, in best case, accelerate the economy. This is more or less the most thing to overcome from my point of view. And there are, of course, a lot of detailed topics which are in a challenge in itself. But I think the most real topic to overcome, and these are goals. Let's see where we end up in reaching them and what probably are further support mechanisms to come. But nevertheless, I think the key part that we really need to focus on is a clever, sufficient implementation of the regulation. Yeah, it's a volatile geopolitical topic, of course, and in this area, implementation of regulation will then remain for a time. So if we really stick to implementation right now, that should not be hinder us tomorrow or the day after, and should even accelerate even. Yeah.
Extra one. Justo?
Okay, and I think it's effectively there are a lot of ambitions. So in terms of effectively battery passport, as has been mentioned, so we have to share some information, and so there are sensitive information. Also, all the due diligence that are needed. So it effectively could be difficult to access for that. But I think for the industrial point of view, one thing that it's important, it's to support the recycling community and the industry, because if we have no industrial to be able to recycle in Europe, we could not achieve all the targets that have been in the regulation. So I think a strong support to this industry, because the problem of the industry is that the recycling will be occur after the use of the batteries, so 10 years after, 15 years after the entry in the market, and this lifetime is could be complicated because you have to invest and to develop now the technologies that will be need and be in operation in 10 or 50 years. And so we have a problem of the ramp up, and so effectively, so how to access to the material, to the battery. And so, but the key point is we need to have these plants in Europe.
Okay, and now the difficult mission comes to Johan. If there are any things that you want to support or that you don't agree with, or from your policy officer head on?
No, I think all the points mentioned are very valid. I take note of your comments on the battery passport. It is going to be a major undertaking. My colleague has already mentioned that we have a project running on the first implementation of the digital battery passport, and we expect that this is going to learn us a lot about the implementation. However, it is true that tracking, for instance, the provenance of all the raw materials, tracking the CO2 footprints of all the raw materials is going to be very difficult. We also know that the whole implementation, the infrastructure, the blockchain approach behind it is also going to take a lot of work. So it is going to be a learning process for all of us, including the OEMs. Nevertheless, I think in the long run, it will certainly support the European industry, because it is going to help us weed out, so to speak, the dirtiest batteries from the European market. So it is going to help us also to, well, if, of course, on condition that we do develop the greener batteries in Europe, which I firmly believe, that is going to support European industry. In terms of the recycling targets, I think this is not a static document in any case. As already mentioned this morning, there is no target for graphite, which is very relevant. LFP is largely unaddressed by the batteries regulation. And then we also need to think of all of the future technologies, including sodium ion. So I would certainly expect that there will be a reality check in a few years, and that new elements are going to be added to this battery passport.
I think it's a good point, because the question was about how can technology help us deliver on the obligations that we get with the battery regulation. But of course, the battery regulation is not something frozen, and it also needs to adapt to the fact that technologies in battery chemistries will be evolving, and we don't have a target on graphite. LFP is quite unaddressed. Solid state batteries, at some point, they will come. Sodium ion batteries are also here to stay. So this battery regulation is here to stay, but it will have to evolve. One point I think that also we forget to communicate about is that we are kind of pioneers and trailblazing, because batteries are not the only application that contains critical metals. CO2 footprint is important for batteries, but also maybe for electrolyzers, fuel cells, electronics. So actually, we are cooking up a legislation that will be actually the baseline for maybe other obligations in other types of value chains. And this is something that is quite impressive, I have to say. Hans.
That's absolutely right, especially when it comes to the battery passport, which is more or less a blueprint for passports to come. And another topic is the CO2 topic. We have standards already out there, which are counting, for example, on PPAs, but there's a new way coming out from the battery regulation, which probably has some difficulties in its execution, because if the the solid, let's say, business model for the energy transition is let's say, busted, then there can be projections on the decarbonization, but where is the money and the motivation coming from to do it if PPAs or direct links do not contribute on the private side anymore? So these are really topics that need to be very carefully designed and implemented. And as I said, the battery passport is a blueprint for passports to come. And I said it already before, for SMEs, the backbone of our industry, we really need to be careful what to implement, because right now they are only seeing the administrative burden without any benefit for themselves. And this will in the end hinder business instead of accelerating it.
The general question is, when is setting the bar high too high, right? And you need to make sure everyone can follow that ambitions. And also, it's true that most people that are in PV and wind and electronics and hydrogen are not very much aware of the battery regulation, although at some point it's going to fall on them as a blueprint for their sector. So maybe that's also something that we, from the battery field, when we meet others from other fields, we should maybe also try to create bridges and communicate with them so that they know they get better ready. I have no idea how we are doing on time, but I would just continue with maybe more specific questions to some of you, because you are not involved in respect with the same kind of activities. So I just wanted to maybe a bit tailor-made some questions to you. I will start with Justo. The respect project, of course, this is very important. How can you summarize its contributions to actually the key policies that we have in Europe and that we want to strengthen, like resilience, competitiveness, and strategic autonomy?
As I mentioned previously, so recycling is indispensable for the security and sustainability of the CRM supply for the clean energy transition. So it's the key message, because the recycling could provide us so the secondary resources that will be needed for the future production of batteries, but also the CRM is also needed for the other industry for the energy transition. For respect project, as has been demonstrated by Antoine, provide us some good insight at this moment, because we developed several recycling routes, so the conventional routes, and so the direct route, and so we provide some results that are very encouraging to demonstrate that we could achieve the main targets of the regulation. So that's important to highlight that. And so respect project, but also the other project of the Horizon Europe project could demonstrate that we could achieve, or if it's difficult to achieve some targets. So it's important to continue this effort to support the industry to fill the gap for the next steps.
Maybe one point that also sometimes crosses my mind is that when we talk about circularity, it's not only about recycling, obviously, and what you can see, for example, in BEPA is that when we develop advanced materials, we have more and more emphasis now on reducing the CRM content, because circularity starts at the design phase, and of course it finishes with the recycling. And it's good that we can cover both the upstream and the downstream part of the circularity together.
No, yes, of course, and the recycling is important effectively to retrieve the material, but the first idea is to reintroduce this material in the new production for the same application. But as effectively there are some evolution in the chemistries, some material will not be needed with the same amount in the future. And so, for example, effectively, we increase in some batteries, we increase in some chemistry, we increase the nickel, but we reduce the cobalt. So effectively, in 10 years, we'll access to material with higher content of cobalt, but it will be needed for the future production. But this cobalt could be used for other applications, and so that it's important also to highlight, not only for the same industry but for other industry. So recycling could effectively the second resources for raw material, not only for the EV battery when we speak about the battery, but for all the industry for that work for the energy transition.
It's very much systematic thinking. I think it's important to stress it. It's not just recycling of batteries operating alone in a silo, obviously. Coming back to CEA, we heard about direct recycling. I've heard about it for many years, and I tried to follow the topic. It's very exciting, I have to say. We have, of course, to be able to come to an industrialization of such a technology. Now you are about halfway at Respect, if I'm not mistaken. So what do you see as the main big industrial challenges if tomorrow somebody wanted to say, okay, let's go direct and let's industrialize this technology? What is the big pain points that you envisage?
Well, I think the main challenge for direct recycling is what makes direct recycling attractive. It's at the same time you are a recycler, meaning that you need to be able to deal with the diversity and heterogeneity of waste stream, and you need to be able to treat high volumes. And at the same time, you are a manufacturer of active material synthesis. And for this, you need to perfectly control the quality of the input material entering your process. And somehow here, there is a kind of contradiction. So from my point of view, it could be quite difficult for a recycler on its own to implement a direct recycling process for scraps, for instance, because we will see that all scraps are different from one gigafactory to another. What I see as a possibility is that cell manufacturers sees direct recycling as an opportunity, and that some joint ventures are created between a cell manufacturer and maybe a provider of a direct recycling process. And this way, the recycler will have a really good knowledge on the input material. And I think this is the more realistic scenario to see the emergence of direct recycling technologies at industrial scale.
And so, for example, the high scrap rates that we see as a major bottleneck and a problem for gigafactories in Europe could actually be one driver for a direct recycling approach?
Definitely. Yeah, definitely. But you need to have a really good collaboration between recycler and OEMs. And today, if you answer to a tender for the recycling of scraps, the level of information you get from the OEM or cell manufacturer is not always at a sufficient level to allow direct recycling. We have seen this morning that a lot of characterization need to be concluded more than with conventional processes. And here the exchange of information is key.
It brings me back to the point that France is often echoing. Data exchange is actually more important than ever if we want to build a solid business case in Europe for the battery value chain, including for the recycling part, actually. Do you have other challenges that you wanted to list, or that's already quite a long list? Now for graphite. So you said that there are no targets that are ambitious enough. We don't have a target for graphite today. We don't have industrial scale recycling of graphite today, right, in Europe. What do you see as the main challenges to set up such a footprint in Europe? What is missing maybe from a policy point of view to go from not having something to slowly developing this activity in Europe, Andrea?
Yeah, because as Antoine presented, graphite recycling is very possible, and we are very confident that we can recycle both production scrap graphite and also end of life graphite back into the batteries. So I would, to make a bold statement here, in 2040, I believe that the main next generation anode material will be recycled graphite. It has the potential to outcompete virgin graphite technically and financially, and I hope there will be a lot of silicon anodes, but I think volume-wise, recycled graphite will be bigger. So that's, of course, very good news for the Green Deal industrial plan, but and I think that will happen anyway. But as you say, there are no policies really incentivizing graphite recycling, and that can be specific targets, but it can also be on the recycling efficiency, for example. We are now discussing drafts where you can, in the latest draft, choose whether you want to include graphite or not in the calculation, which makes no sense to me. That's not an incentive. So you need to align on one way to calculate that, and graphite should definitely be a part of that, in my opinion. So the main challenge is there is no supply of graphite available for recycling today. So of course policies can speed that up, and there's limited demand, and that is also up to us. So we have to maybe teach our customers that this is a very good material. It's an immature industry.
This is quite strange because this is maybe one of the material on which we are the most exposed to the outside world. Yeah. It's kind of a strange situation.
Yeah, as we discussed in the coffee break, Fabrice, we just last week saw some new export controls on graphite between China and the US.
Yeah, so materials can become weaponized, so we have to keep an eye on it. Yeah. So, Johan, a target for graphite maybe in the future. And 2040, I think that I don't know where we will be, but somebody has written down 2040 as one of your ambitious targets. So we'll come back to that. Thank you so much. Logistics. I hear from people telling me that it's actually easier to export from one European country sometimes to Asia, the black mass, and I believe this is true, rather than exporting from one country to another country, because some of them still use fax, for example, or this kind of limitations that we have. So I know that you covered this in your presentation, but maybe it would be useful to try maybe to summarize what are the main challenges that we have, logistically speaking, if we want to make recycling something that is not just theoretical, but really happening.
So the challenges identified are the safety, the legislation, and the market maturity. On the safety, I think the major challenge is the facility, the storage of lithium batteries. And also, this is something I didn't mention, but the sea transportation is something quite complicated regarding the safety, as the transportation can last about 45 days. And if something happens during the transportation, it can lead to very, very complicated situation, as the value of a ship is really, really expensive, and of course for the operators on the ship. So this is something today really complicated to organize the collection of the batteries in the island, in the different islands. On the legislation, so I think the major things is about the hazardous waste status, and this is something we will have to deal with in the coming years.
as the law will be modified and it will be considered as a hazardous waste. And the last point, the market, of course, this is a challenge today because the volumes are low, they are unforeseen, but we think also that it will change in the coming years, and I think it will be improved, especially regarding the volumes which are low today. It will be with the year, the volumes will grow and it will come easier and easier regarding this point. But today, this can be a challenge.
Just one question that is crossing my mind. We talk more and more about battery swapping and discussed in the past with France about that. Does it bring extra logistical challenges if the model of battery swapping would be gaining traction in Europe, like it's gaining a lot of traction in China, by the way?
This is a good point, effectively. I think this really an issue for the car maker. There are only a few car makers who use today this swapping method. But I think this is more an internal issue of the car maker than something for the global market. But if it's come to be something usual, then we will have to deep dive and find solution.
France, I don't know if you want to react.
Yeah, this is addressing a few heads of mine. One, of course, the ASEA one, because we at ASEA were often talking also on battery swapping, but we did raise this topic also in Working Group 5 Batteries Europe as a challenge to tackle. But there is a kind of, and I've been with Frank Kindermann from NIO recently on stage. We have had a good debate. BMW being on the one end of the, let's say, high integration, and NIO being on the other side of battery swapping, was quite interesting. And it was in the end even not said. It was kind of harmonized. Even this is a completely different approach because everyone has its benefits. And so NIO decided to go this way with a lot of capital and other objectives. We tried to come from an engineering point of view and say highly integration is an enabler for efficiency. So this is our way forward, and I think this is also in terms of safety and so on very good. There are some disadvantages, of course, but nevertheless, this is the way forward. And we from ASEA, this is the club of the automakers, we are convinced that swapping is definitely a part of the battery world of the future, but it's more linked to commercial vehicles because looking at these light vehicle trucks, for example, or even heavy duty trucks, you have these 200-liter fuel tanks on the side, which you easily can change during the load and unload of the goods. And additionally, there are some spillover effects for the grid on this area, because if you manage to get down or to cut down your peak performance that you need from the grid, it also decreases the costs dramatically. For example, we did it for the plant in Leipzig. The batteries being stored before installed in the car are used as a stationary storage. And this brought alone in Leipzig the cost of the grid connection without any payment for energy. Only the connection is 100,000 euros less due to this stock that we now use to reduce the peaks. And I think so there are applications which are more valid to have integrated system, which is also supporting the grid in another way, because you don't need to charge the batteries with 300 kilowatt or something. Even a megawatt is for commercial vehicles already out now. and this is it. So there are some applications which are really very, let's say, valid for this topic, and others aren't. And it depends on the use case in the end.
I have to say, I never thought about the grid dimension in the battery swapping, but that's very interesting to put into the debate. Now I'm coming back to Lomartov. So we heard that indeed battery waste seems to be leaving Europe. I think we have to recognize it. What do you think we could put in place in order to reduce this, or maybe even stop it, but at least reduce it to sufficient extent that it can stay in Europe and actually make the case for battery recycling capacities to actually be developed here?
Yeah, that's the question. There are some measures already foreseen to prevent this, like the regulations to prevent illegal export of waste. All these material recycling targets can also contribute, or at least theoretically can contribute, and we need to recycle inside Europe. But yeah, The question is that we need to increase recycling capabilities, because if we don't have these recycling capabilities here, we need to export. There is no other solution. And to have these recycling capabilities, so there is need to invest in these new recycling plants, also in research and development for more efficient infrastructure, maybe local hubs for local recycling, or at least disassembly, and optimize the logistics. Because one of the things we also saw in our LCA study was that the recycling outside Europe, despite the transport, is more cost effective, more profitable. So we need to increase the capabilities and make something that works really well and in a cost effective way. And this might require at the beginning also some support, some economic incentives for the recycling, like subsidies for this local recycling, rewards to the use of recycled materials to start moving the market. And yeah, this kind of things until we have a system that works at a scale and that is sustainable economically by itself.
So any hard line on saying battery waste cannot leave Europe anymore? This is not something that you would be promoting. A hard line which says battery waste stays in Europe. This is not something you would be promoting as a solution, or it's too difficult to put in place.
No, I don't think so. Indeed, what we show is that if we have plants with high capacity, they can be competitive, and by integrating advanced technology, or even the direct recycling, which is still in a premature stage, we can have feasible solutions. But at the moment, what we need is to reach economies of scale and some support to do so.
It feels a bit like a chicken and the egg problem, and I always come back now again to France. Sorry, France, but it's about
that's what I'm here for.
If there would be data exchange and strategies exchange between the different players in the value chain, maybe this issue could also be tackled better, because those who want to recycle, they say, I don't have recycling capacities in Europe. So of course they need to find a solution, and we cannot blame them for that. And those who have the waste, they say, well, those who want to recycle, they say, yes, but there is no input, so why should I invest? And because of this chicken and the egg, we're a bit running into a wall. So it's also, again, a pleading for more exchange up and down the value chain in a safe space, if you can build on that.
Safe space is a good word, but I think the safe space has even a broader objective. And I think the reason that production scrap is considered as SLQ content is already an enabler. We have significant numbers then to talk about, even though there's no post-consumer scrap already here. And I think this is really, let's say, fueling somehow the business for recycling. And in the end, because some say, why is production scrap considered? Therefore, one thing is you will have production scrap, and if this uptake in electromobility is growing, the part of scrap is also growing, and it's more than the ones batteries coming back from the market. But as economical operator, in the end, we really try to bring down the scrap rate to almost zero if possible. The more realistic target is 3 to 5%. But only this 3 to 5% in this growing market are really helping the recyclers to get a kind of sustainable business, which then can be used as step one for the investment, and then be extended if there's the mass market coming from the, let's say, post-consumer scrap. And it's also very necessary to have this kind of starting point, which mean there's a factory, but this is not fully occupied already, or it's just an extended pilot line. I don't know, you know what I mean? To really have also this impact from research on the improvement of the factories of tomorrow and the day after, to really get the CO2 down, the costs down, the volume, and the great materials out. This is all you need to usually start on a smaller scale, and then and this smaller scale is already a big share of materials coming back, pushing and giving some money into the recycler's hand. And then this execution and this business really helps to develop, complemented by R&D, to have a hopefully successful closed loop material supply chain in Europe.
Thank you, Franz. Justo, if you want to react, because you are the recycler here on the stage, so feel free to step in, obviously. Huh?
I think effectively, as I mentioned previously, that if we want to have an efficient recycling business, we need to have access to the material, and so battery must remain in Europe, or perhaps at the beginning it could be perhaps we have a mixed with material coming from outside. But in any case, we have to support this industry to start. And to be ready at the right moment when the amount of battery that will be recycled will be enough for all the industrial.
Okay, we have the clean industrial deal coming up. Normally it takes 100 days, I understood. So I think we should not forget to voice the messages to the Commission. Before going to Johan, I just have another question to Franz. The OEMs, of course, they invest into battery recycling from a competence building and understanding point of view. But BMW seems to invest quite a lot, as you have said today in your presentation. So what makes the battery recycling of BMW a bit different from the other industrial players in the field? What sets you apart?
Yeah, I think the good thing is, if you look at the 3 competence centers that we soon have up and ready, the first one, the cell competence center, is really bringing us on the edge of technology with the cell makers. And even so, everyone says Koreans and Chinese are leading edge. And that's not fake, we really improved the spec with them to have even a better result on our vehicles in the end. And probably this commitment is also a part of the success story of BMW, even in these days. And we were also very aware of that this product and process development needs to go hand in hand, because we just said the supply chain is now red flagged for the Chinese and Korean flagged and so on. We need to have this blue flagged supply chain from Europe. But that's all to upstream, and upstream, of course, also considers design to sustainability. And now, as we have established this, and this is equipped with workers, and yeah, we have now the Neue Klasse more or less in front of the door running. We would like to do the next step in recycling, and really because we see also from a geopolitical point of view, from the regulatory point of view, and also from our 3 strategic pillars, one of it was circularity, that we really are committed to make this happen and try to get as much as secondary material as possible for the new batteries and cars to be equipped. And this center is our contribution in the improvement of recycling technology and processes as well, to spread then with the supply chain participants and having collaborations, and also making kind of decisions or recommendations for the investments to come for a successful recycling business.
Thank you, Franz. Apparently, I got the message that we speak too much, so it's always a good sign, actually. But we will maybe finish this round of questions before taking the Q&A with you, Johan. So, from a battery recycling R&I point of view, of course, we have some indications of what we want to do in the BEPA SRIA, but we also have messages coming from the floor here. How do you look at it? So, what do you think are the big topics to address when it comes to recycling R&I? And of course, the last question that we always have is that, is there going to be enough money to support that? But that's up to you to answer this question.
I'll try to be as short as possible. All very good points that have been mentioned. I think from an R&I point of view, we already indicated that we need to get ready for this whole zoo of different battery chemistries, battery configurations, cell types and everything, which is going to be very complex, of course. That's also one of the reasons why for instance, solid state projects, we already ask the consortium to think about the dismantling and the recycling of the batteries to anticipate this. Furthermore, I think the economic aspect is going to be very important, because this is going to drive the tipping point between second life or recycling. If it is expensive or even a lossy process to recycle, there will be more of an incentive to reuse these batteries in a second life application. And then finally, everything needs to be as clean as possible. That is going to be our biggest distinction point regarding to the rest of the world, but also just to help the social acceptability in Europe, because it's not very sexy to have a recycling plant in your backyard. So we need to make it as smooth and as painless as possible to get this installed and up and running. And the money, yes, my crystal ball, I left it at home, but no, I think the realization is there that batteries are really crucial for Europe, and I think we can count on continued support, at least at the same level that we have now.
And not just from the Commission, but also from the member states. Huh? I mean,
Yes.
The cancellation of the
different
battery for
sources.
fuel in Germany is an example that
Yep.
we should not have in other countries, obviously.
Yeah, the Innovation Fund will complement as well. We have this 3 billion that is being made available. So yeah, there will be different contributions being merged into a big package.
Okay, the more the better, I would say. Now I have to move to some questions from the chat, but I don't see questions in the chat, Elisabetta. So there are no questions in the chat. Okay, that's even better. Well, I don't know how to say that. How much time do we have left? Oh, so we should close. Okay, so I had another question, but it will be for the next, unless somebody wants to give a closing statement.
No, it's not
quickly.
a closing statement. I just want to add, because I think it wasn't really on the table right now in the presentations and also in this discussion here in the panel, is the social acceptance. We recently invested in a plant, starting to build it now in Bavaria, on building batteries in Germany and for our plants in Germany. And the greatest threat we had, next to the permission topics, of course, was hopefully we do get the social permission.
No, but
because
it's
the
important.
neighbors need to really, as you said, the backyard, need to accept it. And we've seen good projects failing because of the social acceptance. And I think this is also a topic. I don't know how to tackle this in general for us as Europeans, but this is something we really need to consider, because we can have the biggest ideas, the best plans, the best business plan, but then in the end, the social acceptance says, no, not in our town.
I have a recommendation to close the session. We're all going to be at many Christmas dinners, and there's always somebody who's going to talk to you about batteries. Just bring the good messages about batteries, and it helps with the social acceptance. You know, one stone at a time. So,
but if you want a social acceptance of your plant, you have to invest in the north of France, because we have for our 2 plants in Dunkerque, so we have the obligation to have a public hearing, and so we receive the public are very happy with all this investment, not only for from Orano, but also for Vercors and so other gigafactory, and so they are really the public accept really this new industry. So come in France.
maybe Respect should make a map of public acceptance across Europe, and then you know where to invest. I don't know. Okay, so we will maybe conclude. So thanks a lot for the panel, for the quite engaged conversation. I think we could have spoken maybe a bit more, but Elisabetta has set the time to be finished now. So thank you so much for those that were online following us, and also in the room. And I wish you a nice continuation of the day. Bye-bye.
to all our speakers and panelists for their contribution. So we hope that you learn more about respect, but also the CRMA Act, and also the opportunities and challenges to contribute to fill the gap between the aspiration of the Critical Raw Material Act and the practical reality. Thank you very much to also the organizers, and so Elisabetta for the support. And so thank you very much to all of you, the attendees here in the room, but also online. Thank you.